Hey guys, welcome to the shop. Make sure to watch part 1 first, the lead up to this, where we're making some parts for the do-all bandsaw. And then we go to finish up this part that I have in the lathe here, and then, of course, the lathe breaks. You know, that's the way it goes with some of this equipment, but we figure out a way to fix it. But man, it was an involved little repair. You'll see. Thanks for watching, guys. I really appreciate it. Let's get started. Alright, so I just quickly turned the lathe right back off. It is making a noise that it's never made before. Since I've had it. This lathe's been trouble-free up to this point, and now I think I've got some motor issues is what I believe. I'll get you around here, we'll look at the motor, I'll show you, but unfortunately it's turned from a saw repair to a lathe repair, I believe. It's always something. I can guarantee that. But anyway, let's see if we can figure out at least what's wrong with this thing. I hope it's nothing serious, but we'll find out. Let me get you around here. I'll turn this thing on. You'll see what it sounds like, and then we'll go from there. Well, here's the back of the lathe. It's dirty, like any big old lathe that doesn't get cleaned often is. But there's the motor. It's a single horsepower 220 volt. It is a single phase 220 volt 5 horsepower ball door motor. It's been really reliable. Every time I turn the switch off on this machine, it always brakes really hard and shimmies the belts. That's common, but it's making a growling noise now. And I'm no electrician by any stretch, but I'm thinking that possibly this motor being a single phase should have a starter winding and a centrifugal switch. And I'm thinking that possibly that centrifugal switch is stuck on, because or else it probably wouldn't start. It is starting. Let me show you. I'll turn it on really quick and then turn it back off because I don't want to damage anything if it has issues. So listen close. Okay. It has always stopped violently, like braked hard, but it's never made that growling noise like it's making now. Anyway, let's get this thing out of here, get it on the bench, and see if we can figure out what the deal is. Well, I should probably get back here and clean a little more often. Of course the power's off to this thing. Completely unhooked. So for wires like this being a single phase, it only has, you know, 2 and a ground. But to mark them, I like, this is some cloth stickers. They're all labeled. I don't even know where I got this from. But anyway, it's called Mighty Mark wire markers. So you can just stick, you know, like 0, 0 on your corresponding, 1, 1, whatever. Line 1, line 2, line 3. Really nice labeling system. I'm not even sure they're still available, but you get the idea. Handy. So this is actually a 3 horsepower. I thought it was a 5 this whole time. 1725 RPM. It is a 115 or 220 volt. It is a 184T frame. Ball door industrial single phase. Okay, I just sure hope that I don't have to try to buy one of these or need to buy one of these. Hopefully it's something simple. Well, I'm going to clean it up and then start tearing it down. So I want to look under the cover where all the capacitors are. Make sure I don't have any that are swollen or leaking. have to make sure these are discharged, and then I don't know. I don't see anything bad. I mean, nothing obvious anyway. That tape I don't think is factory. Could be. Alright, so I've got the cover off this thing. Just doing a quick visual. See if I see any leakage of fluids from these capacitors. This is the run capacitor and these are the start capacitors is what I believe. This motor did start and run. It just ran kind of funny. So I'm just going to do a quick check on these. I already shorted the leads out on these just with a screwdriver to make sure that they're not charged, because that could make you have a bad day. Let's see. This is a 20 microfarad run capacitor. And that's 19.6 is what it's reading. I don't know, maybe that's good. I'm having a hard time seeing what is actually wrong with this. But man, I wish they wouldn't have used some cheesy tape and foam that degrades. Also, the connections on this is just horrible. These little blade style connectors, I hate those things. I mean, a breeze could have knocked those off. But they were all connected and I don't see any heat. So I'm going to solder these on just to make sure they're a good connection. And then we'll pull the motor apart and look inside. I'm no electrician. I'm just trying some of the few things that I know to do. So check out that. That one's already broken off, and look at that. It's just a horrible way to connect stuff, in my opinion. So I'm just going to clip these off. And then just directly, wow, that wind's kicking out there, directly solder these to the to those blade connectors here. So this is a pretty pricey unit, this motor. I definitely don't want to have to buy one. Those should not fall off. Alright, so I went to buy new capacitors for this simply just to put new ones in it. They do go bad. The store that I went to did not have them, so I just decided I was going to wait and check the switch in this thing first. I went to Granger. Usually they're a pretty good supply for stuff like that. I did pick me up a new little screwdriver, little electronics Klein screwdriver. I always loved, using Klein tools, even though they're quite pricey. But I think I paid 13 bucks for this little screwdriver. I didn't have a real good small screwdriver. I got a few, but none that I really liked. So I picked up this little Klein, definitely nice, multi bits. Nice little screwdriver. So now I'm going to take the back off this thing. Dirty. Little Woodruff key. We may end up with a do-all bandsaw motor on our, that's the wrong size, on our lathe. Alright, so from just a quick gaze in here, it looks like I was correct. Those starter switches, contacts, look to be welded shut. And how I correctly guessed that, I'll never know. But it looks like I did. There is some excess grease in there that probably contributed to the failure. Man, I was hoping that was a capacitor. Something I could change quickly, something I could get locally. I have no patience. I'll just let you know. Let me, not cut, but get these wires to where I can get this off. I'll get you a good shot of it. I was hoping it was a capacitor, but it's not. This is where your multicolored tape comes in handy. Just trying to remember this stuff is almost impossible. Pictures help really good too, just cell phone. Hard to get stuff wrong when you take the time to code everything. But to pull this switch out, I have to make sure everything goes back where it's supposed to. So I'm just going to color code what connects with what. That way I can get this stuff back together properly. There we go. See how hot that's been? Hopefully you can see that. I'll get you a better shot, but that's toast. So the grease. There's the centrifugal switch. And what looks to be an overgreased bearing. Alright, so let's get a closer look. Here you can see here and here are two paddle switches, just contactors that, you know, like points almost. And they're welded shut. You can see this one's almost burnt through the board. So it's definitely our issue. I don't know what the designers of this were actually thinking. This should not have a grease fitting on it. It should be a sealed bearing back here where this switch is. There's no exit for the excess grease to go. So the only place the extra grease could go when somebody pumps grease into this thing is through the bearing and into this switch area. I mean, it's not crazy amount of excess grease, but of course it has it. You can see it's almost closed this switch completely up, all the grease. This should have a sealed bearing in the back. Let me get you a shot of the back of the motor here. This should have a sealed bearing and no grease fitting. I don't know exactly what they were thinking. I mean, probably from the combination of a poor design and then improper maintenance on my part, and probably on the guy before me, you know, pumping this thing full of grease. I can only remember greasing this thing once. I mean, it doesn't have a ton of grease in it, but it's obviously got enough to cause issue. So there you go. Should be a rubber sealed bearing, no grease fitting. You run it till the bearing gets bad, you change it, or you get a new motor, whatever. But that's what caused our issue. So, no fixing this thing today, unfortunately. So after giving this some thought and inspecting it a little deeper, this side of the switch is perfectly fine. It's not in great shape, but it's serviceable. I'm having a little hard time finding this exact replacement, although I know you can get it. I just haven't actually found it yet. And I don't want to wait days to get this lathe at least running. So I'm going to try to find me a new one. I'm going to order it. But in the meantime, I'm going to fix this switch so I can have a lathe, because I cannot stand not having a lathe. That's really the heart of the shop, in my opinion. So I'm going to make this arm over, because it's burnt up. I'm going to make this pad that this other part of the contactor goes on. I'm going to make the contactors and install this until I get a new one. Shouldn't be too bad, I wouldn't think. It's not like it's that complicated of a unit. So as you can see, my mini lathe is back together. For those who followed the channel for a while, you know that I've had this thing tore down to do a bearing swap from standard roller bearings to tapered roller bearings. I had to have a lathe in order to fix my lathe. I had to make the contacts somehow, so I stuck this thing back together real quick, and the chips that you see on the lathe bed are the first chips that this thing had made. I can't say that it made a huge difference, although that the spindle feels quite a bit smoother rotating it by hand. All that I've turned on is copper, and so I can't say that it made a huge difference or not. We'll see. It's working fine. I did not film the assembly, simply because this was strictly business, trying to get the big lathe back up and going. But, we'll touch on it later, and, I'll let you know how it performs after the swap. Alright, so there's a little contact that I made, just turned it out of just a piece of solid copper. I'm going to put a little silver solder on the top, hopefully to help it get a better connection. I don't know that that's strictly necessary. And I got a little flux on the top of it, just here, stay sealed black. This is some awesome stuff. If you're doing high temperature brazing, you got to have a brazing flux that matches the temperature, or it's in the range of the temperature of the brazing alloy that you're using, or else it just doesn't work. Put it on a piece of graphite, and wearing some glasses. Not only do they protect your eyes, but they actually help you be able to see what's going on a little better. That's it. I need to just turn that flat on the little lathe, and it should be ready to install. So for as little as this is going to be used, I don't think probably coating those was going to be necessary, but you get the idea. The original ones looked like they were coated, and I'm sure it was some sort of silver. So that's what we used on these. Now I'll turn that off flat. You can see it's still got a dome on it. Just knocked it all the flux off with a wire brush. There's the first one that I done. This is our spring connector. You're never as good at the first as you are at the second. There you go. That's it. Just need to turn it flat and drill and install it on the little plate. Alright, so now I need to seat this lower contactor here into this brass plate that I've only got one rivet in so far, so I can swing it out and press this in. I'm going to use the arbor press to swage that in there. That's it. I can put my other two rivets in. That'll get everything lined up. Solder my wires on. And that switch is pretty much done. Alright, so fast forward a little bit. I got this thing back assembled and it's ready to test, I believe. Now the only idea behind this repair is to get me by until I can get a replacement part. The other contactor in this that I didn't replace is not in good shape. It's serviceable, but I don't think it will last very long. So it being the holidays and stuff, I could not. Nobody's answering emails, nobody's open to call. So if I can save a week of downtime by building the components of this switch, I mean, it was easy enough. Probably took me, I don't know, 4 or 5 hours max. It'll be worth it to me. I just hate to be without a lathe. So let's get this back in the lathe and see if what I did fixed it. And I can start off where I left off. Here's where the labeling pays off. You don't have to guess. I need to get in here and do a good cleaning. Luckily I had all the parts and pieces I needed to make that switch. Hopefully this works. Should. So originally this machine is it's a 5 V-belt machine. So you can imagine how much power you could run through 5 V-belts. This was either originally a 7.5 or a 10 horsepower electric motor, I believe. Of course it was 3-phase. So there you go. I'll just tension that belt and then that's it. We can try it. Alright, drum roll. Works. Fixed it. That was worth it. Alright guys, I'm happy to say that this thing is usable, at least till I can get the proper replacement part. I don't plan on running that switch that I made long. But if I can get a week of running out of this thing, I'll be perfectly happy with that. It was worth the few hours that I put into it to get it back up and going, because I got stuff to do. Anyway, most of the motors that I work on are 3-phase and they don't require switches and stuff in them. Even at my day job, we don't deal with single-phase motors usually, so that was a lucky guess on the failure. So thanks for watching, guys. I really appreciate it. Send me an email if you need anything. Click on the little guy to subscribe to this channel. Thanks to my viewers, patrons, and subscribers. That's it. Thanks for watching, guys, and I'll see you next time.